Hello grade 12s. In this video, I'm going to go over a question from your textbook. Okay, so on page 318, it's question number 6. It's one that's a bit more challenging, so I thought it'd be good to make a video on. You'll see there are different ways to solve questions like this, and as I go through it, you'll notice maybe I could have combined two steps and made this shorter, but this is just my thought process, raw as it was when I was figuring out this question myself. I only realized after I had done two steps that I could have combined them, and you'll see that as I go through the solution. So it may seem a bit long, but it hopefully not time-wise long, but the solution may seem a bit longer, but you'll see that you can we can combine two steps and not do it the same way I did. But let's show you, see if you catch those steps. Okay, so your target reaction is this. N2H4 and oxygen as your reactants, and these are your products. Now let's look at the four reactions, and we've seen questions with two, we've seen them with three, but in our video so far we haven't seen four. So using these four reactions to come up with the enthalpy, we need enthalpy of this reaction here. All right, so this is our target reaction. Okay, let's analyze. Now we need let's look at this first one. NH3 we have to eliminate. It's not part of the target reaction, so that has to be eliminated somehow. That means there must be some NH3, there must be an NH3 somewhere else, and it looks like it's right here. So it looks like we're going to have to flip this at some point. Okay, what else? Equation 2. Look, we don't have, oh, yeah, we don't have N2O in our target reaction either, so this will have to be flipped, looks like, or rather canceled. Now let's see if we have to flip it. So N2O, where else does that appear? N2O, H2O, 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 N2, right here. Okay, so this has to probably be flipped. So maybe we'll start there. Okay, just dive into it. Let's begin. All right, so number 2. Okay, we're going to flip that. Multiply by -1, and we get H2, H2O. Okay, so it's flipped, and what we have to do to the enthalpy value here is just change that sign. So it's no longer minus, it's now positive. Okay, next, I'm going to flip, I haven't talked about this yet, I'm going to flip number 3. Okay, so I'm going to multiply that by our equation number 3, multiply that by -1. Now let's see. Um, we have waters on our product side and reactions 2 and 4. So moving water to the other side isn't a big deal. But we actually need N2H4 to be on the reactant side. Um, so let's do that, right? Otherwise, if we didn't, look, since we flipped number 2, we'd end up canceling N2H4 out, and we don't want that. So let's flip number 3. Okay, so go ahead and do that now. So products become reactants, so H2O. Okay, similarly, that now changes signs. Okay, so it was minus, it's now going to be positive, right? So double check that I'm doing this all correctly. I'll figure out my calculations at the end. But for now, let's just leave these signs, rather not add anything up until we're finished. Okay, next. Here is where I realized, I think I'm going to need to do something else. So on our second reaction we flipped, I should have also multiplied that by -3, because I'm going to want to cancel out this N2O. And look, I've changed it now. I flipped the sign, so it will cancel out here, except I need this to be a 3, rather. I need this to be a 3 because this is a 3. So let's take our what's now going to be our fifth reaction. So let's label this over here. This now became, after multiply 2 by -1, this reaction is now our fifth reaction. So I'm going to take our fifth reaction and I'm going to multiply that by 3. Okay, and I get, okay, let's rewrite that. Okay, now we're going to multiply this by 3, and this is now reaction 7. Okay, so let's keep track of this. Um, this reaction 7 came from reaction 5 right here, which came from reaction 2. So I'm not looking at reaction 2. Reaction 2 has been modified quite a bit. So the latest one now is reaction 7. Okay, continue. Now I want to scroll down a bit, see if I can do that here. Okay, so I'm going to write down what I'm thinking. I'm going to get rid of, or to eliminate, okay, so here is reaction 4. Looks like a 9, it's really a 4. Here's reaction 4. I have a 9 hydrogens on my product side, right? Don't want, your target reaction doesn't have that, so we want to get rid of that. Looks like I can do that if I multiply this by 9. Okay, so let's do that now. So 4 times 9, and that's going to be reaction 8. All right, so 9 H2 plus 9 over 2 O2 and 9 H2O. Do the same thing to our enthalpy, and we get negative 2, 5, 7, 4. Okay, so this is the latest reaction. I'm gonna try to keep this organized. Sometimes that's the hardest part. So I have reactions 7 and 8 so far that are now modified versions of previous reactions. Okay, now a lot of things, that what I've done is the flipping around, the multiplying by 3, multiplying by 9. A lot of things have canceled out, and it's only upon looking at the reaction and figuring out, I might be able to now cancel things out, everything seems to be in the right place, that you can then finally decide to say, okay, I think I'm going to add everything and see if it works out. And it will work out, because I've reached that point. I'm going to now add everything. So this is where organizing all of your equations will help. You need a bit more room though. It's going to look messy before it looks neat. So let's change colors here. Now that I'm adding everything together, I'm going to make a note of what I'm going to do, so hopefully it'll help you follow along. I'm going to add reaction 1 that I didn't change. 2, I'm going to add reaction 6, right? Then I'm also going to add reaction 7 and 8. Okay, and they look like this. So reaction 1, okay, reaction 6, next reaction 7, That is 951 kilojoules. Okay, finally reaction 8. Right, and its enthalpy. Okay, I want to double check all of my enthalpies. Okay, so do we get them all here? All right, so reaction 8 is minus 25474, right? Reaction number 7 should be 951, perfect. Reaction number 6 should be 143, perfect. And reaction number 1 is negative 1010. A little further up, negative 1010, good. Okay, there's a lot happening, right? I want to make sure I'm keeping track of things, right? So now, the easy part, hopefully, I'm going to start eliminating. Okay, let's start at the top. 2NH3, find 2NH3 here, perfect, that's gone. Okay, 3N2O, 3N2O, do we find 3N2O anywhere else? We know that this is not part of the target reaction, so hopefully it is, and yes, it is right there. Remember, we multiplied by 3 so that we can cancel all that out, and it worked. Waters, 3 waters. Okay, we have to get rid of this. Let's find waters. There is 1 water here. Okay, where else? 1 water, 3 waters there. Okay, so we got to figure out what to do with that, but let's cancel out these at least. Okay, let's continue now to reaction 6. H2O, H2O here. Will that cancel out anywhere else? Yeah, looks like it will. Look, we have an H2O here, and then we have on our 8th reaction, we have 9 H2Os, right? So it's not going to cancel all 9, but it's going to change this to an 8. Okay, let's continue. We have, where are we? 9, we're already here. 9 over 2 oxygens. So oxygens are here. Okay, so this is a bit. It's just math, right? So this is just fractions. That's a half. That's 9 over 2, which really makes this an 8, right? An 8 over 2. So 8 over 2. We simplify that, and we can write 4 oxygens. Okay, so that's what we have there. What else? Let's look at reaction 6. Have we covered everything in reaction 6? That canceled out. That canceled out. Good. Reaction 8. 9 H2s, right? We multiply by 9 so that we can cancel those out. We haven't done that yet, so go ahead and do that. All right. Reaction 1, we cancel everything out. Looks like we can start to add everything now. Okay, so back to green. Okay, so here we have 1 and 3 and 2 H4s. All right, so that means we're going to add them together. It's now 4 and 2 H4. Okay, we have 4 oxygens. We have 4 right here and 2s, and we have 8 waters. So 8 H2O. We add all of our enthalpies, and we get minus 2490 kilojoules. Okay, we're almost done, but not quite. Now, if you look back, I'll scroll up here, look back at your target reaction, we have all of the correct reactants and products, but their coefficients are not right. Right, they all seem to multiply by 4. So what we do to fix that is we divide. Now we can label this as reaction 9, let's say, but we don't have to. Only one step left to do. We're going to divide this all by 4. So that means we're going to get our target reaction. N2H4 plus O2 produces N2 and 2 H2Os. We have to then divide this by 4 as well, and our enthalpy then for our target reaction is minus 623 kilojoules, right? and that's it. Now we can say we have minus 623 kilojoules for every 1 mole of N2H4, or we can just say the total reaction has this enthalpy, and we've answered we've answered the question. So that's it. Hopefully that helped, and you were able to see the thought process behind this.